Okay, so this is going to help us out with how long the future value is going to increase, right? So if we're depositing 360, right, and then we have a quarterly interest rate, let's break this down real slowly. Okay, so first of all, right, let's start with the easy stuff, right? We know that we're depositing 360 every quarter. So this is on a quarterly amount, right? So we know that we got 360 right here. And then we want to know until it reaches $36,000. So when does it reach $36,000? So we have our A value, we have our D value, and what else do we know here? Okay, so now we have a quarterly interest rate. So it tells us every quarter it's 1.55%. So it tells us this. So we don't need to divide by 4 here because it already tells us that we have 1.55%. Okay, again, which is 0.0155 as our I value. Okay, and now since we're looking for how many years here, we know the number of periods. Okay, but if it is quarterly, we know that we have to do n divided by 4 gives us the number of years. So we know our last step, we're going to have to divide by 4. Okay. So let's go ahead and substitute in and see what we got here. All right, so we know we're looking at $36,000. We know we're substituting in 360 bucks 4 times a year, so quarterly. Now, if we go ahead and break down what's happening on the inside here, right, the top of our fraction, we've got 1 plus the rate, which is 0.0155. Okay, now we have this raised to the n. We're not sure how many periods there are. We're going to subtract 1, don't forget. And then in the denominator, we have the interest rate per period. Okay, so this is a little bit more tricky algebraically. Okay, so the first thing that I'm going to do here is that I'm going to divide. All right, I want to move this stuff around here. Let's get rid of this. Let's move that over here. All right, divide by 360. So if I take $36,000, divide by 360, okay, I'm going to get a value of 100. Nice and easy. Equals, now I have this mess here, so I'm just going to write 1.0155 raised to the n minus 1 divided by 0.0155. Okay, so now if we wanted to simplify this, okay, I want to cancel out the bottom by multiplying 0.0155 here, because that will cancel out. All right, so 0.0155. So if we multiply that by 100, all you really do is move the decimal place 2 spots. All right, so I'm going to get 1.55 is equal to, now I have this. I can drop my parentheses, 1.0155 raised to the n. And don't forget there's minus 1 over here. Okay, so we're getting pretty close. Now you should understand here now that we do have a variable as an exponent. So that means we're going to have to use logarithms to bring that variable down. Okay, so if I take the log of this side, the log of this side, this n, I can just move down to the front. So what that's going to leave me with, the number of periods is going to equal to the log of 2.55 divided by the log of 1.0155. Now, why is that the case? Because remember, if there's an n in the front here, I just got to get rid of this. Log 1.0155. Log of 1.0155. So the logarithm techniques are really what we want to make sure that we understand. Okay, so let's take a look at that. I've got the log of 2.55 divided by the log of 1.0155. Okay, and that's going to give me 60.9 periods. Okay, so if I go ahead and I've got my n value is 60.9. Now, remember that it's quarterly, so if I divide by 4, it's going to give me the number of years. Because remember, it's 60 payments, right? So if I do 60.9 and then divide by 4, what I'm getting here is the number of years here is going to be 15.2 years. Okay, so that's the last and final kind of tricky step. Notice that the number of periods is quarterly, so we need to divide by 4. Okay, hope this helps.